Okay, so I guess yeah. So we were discussing target DSA contest 4 T4, right? We have already discussed the problem one, which is max discount one. I guess this one. We already discussed this problem, max discount one. Okay. So in this video, we are like we are discussing this problem. The fourth problem, Fusion League Challenge, Save the Day with Mystic Arrays. Basically, this problem is originally DSA OS problem 3 of that way in our session, right? So, without wasting much time, let's get started with the problem. In this problem, what we were having, this is just a, like, you can say story. The main thing in this problem is we are having a grid of n cross m, something like this, and also we are having a array, threshold array of m size, right? The constraint for n and m are n is up to 10 to the power 5 and m is up to 8. The value of the elements in the grid and the threshold array can reach up to 10 to the power 9. Okay. So in this problem, we have to find what we have to find in this problem is the change select to. Okay. So basically, in this problem, we have to find the number of distinct pairs of rows of this grid which we can choose so that the merged array that will form will be the valid mystic array. So before getting into the problem, let's quickly see what the valid mystic array is. Okay, let's see if array of size m, if we consider array of size m, then this array will be a valid mystic array if and only if for all the indexes the value at array of I should be greater than equal to value of threshold of I, right? If this condition holds, then the particular array, this array, is a valid mystic array. And how we are creating this mystic array? Basically, let's see. Yeah, let's see how we are making this array. We consider basically to make this array. We are having initially we are having a grid of n cross m, right? We are considering two rows randomly, r1, say r1 or r2, right? So, yeah, to make this array, we are iterating over all the elements of both of these rows of these indexes from 0 to m minus 1, right? Array will be of size m. We consider two rows, say r1 and r2. Then the jth index, the value at jth index of that particular array will be maximum of jth index element of both these rows in the grid. So that's how we are creating the array. Let's quickly the sample case. Okay, so let's think for brute force solution. Basically, let's quickly re uh, summarize the problem. Basically, we are having a grid dimensions n cross m, right? And also we are having an array uh, of size m, which we are calling threshold array. And we have to find the number of distinct pairs of rows, say r1 comma r2, such that the array formed by using these rows of grid will be the valid mystic array, right? And the valid mystic array ARR is the one where each index value is greater than or equal to the threshold value. Okay, so let's quickly see the brute force solution for this problem. In brute force solution, we can directly like iterate for both rows. for R1 going from 0 to n minus 1 and R2 also going from 0 to n minus 1. We are checking whether the valid mystic array condition holds or not. We are iterating for each column 0 to m minus 1, and we are checking whether the maximum of both these values, grid of R1 comma k and grid of R2 comma k, this maximum value will be the array of k, whether this value is greater than threshold value or not. If this is greater than threshold value, that means the array we are creating is not valid, because for valid mystic array, the array of j or you can say k should be greater than equal to threshold k. So this should be less than. If this is the case, that I can update the flag value as false, and if the flag value was uh, true, then I can increment the count, and I can at the end return the count value. Overall time complexity for this brute force solution is, for iterating uh, on both the rows, I will be having big of n, gain big of n, and for iterating to each column value of that particular row, big of m. Sorry. So overall the time complexity will be big of n square times m, but n is up to 10 to the power 5 and m is up to 8. So overall time complexity will reach to 8 times 10 to the power 8, which will definitely give us TLE. If you are unaware of the fact that in mostly all the programming languages, in 1 second, almost 10 to the power 8 operations can occur. So this particular time complexity will take us 8 times 10 to the power 10 divided by 10 to the power 8, almost 800 seconds, which is a lot time. Definitely this will give us TLE. So let's quickly go to the optimal approach. So before going to optimal approach, I can like I can say one thing about the optimal approach. If you are seeing this concept for the first time, then it's fine. Like if it's fine if you are not able to solve the problem, but try to get a proper feel of this concept, because this bitmask concept is something which can definitely give you edge over others in actual way. Okay, so let's uh, start with optimal approach now. For optimal approach, basically let's see, like for valid mystic array, we need array all the elements of the particular array which we have created for after choosing two rows should be greater than or equal to the threshold value, right? Okay, this is what we require. M is also small. Okay, whenever you see M or some constraint is too small, the one thing that can hit like strike to your brain is there any possibility to use bit mask? I will discuss in this problem how to use bit masks. Okay, so let's store bit mask of m bits for each row of grid. How? Let's see how we are calculating the bit mask for each row. For each row R, we will calculate a mask value for m bits. Let's say if the mask value for a particular row R is this. What does that mean? If a bit value is 0, the that means that particular index of that row, basically that particular column value of that particular row, is less than the threshold value. If this is 1, that means this particular value is greater than or equal to the threshold value. That's how we are storing the mask. Let's say if we are storing the bit mask in this manner, and uh, then in terms of bit mask, how the question changes. Now the problem has been changed to, like, initially the array of I is max of these two values, right? Okay, let's uh, take a sample test where n is 3, m is 2. We are having this grid 2, 4, 3, 6, 7, 1. Okay, so for this row, and this is the threshold array. For this row, the mask will be as 2 is less than 3. This bit, uh, wait a second, let's quickly recalculate the bits. Yeah, so this is the 0th index. 2 is less than 3. That means the 0th bit should be 0, and then 4. 4 is greater than 3, greater than or equal to 3. Then this bit should be 1. This is the mask value for 0th row. Now let's calculate the mask value for first row. 3 is, this 3 is greater than or equal to 3. So this bit should be 1. And 6 is also greater than or equal to 3. So this bit should also be 1. Now let's calculate the bit mask for this row. 7 is greater than or equal to 3. So this bit should be 1. And 1 is less than 3. So this bit should be 0, right? Okay. Let's see if I am using this row and this row to create a mystic array. So array will be array found will be uh, for this column the maximum value is 7. This and this the maximum value is 4. This will be the array found. And now let's calculate the bit mask for this particular mystic array. 7 is greater than or equal to 3, 1. 4 is greater than or equal to 3. Sorry, yeah, 7 is greater than or equal to 3, so this one, and 4 is greater than or equal to 3, this one. I will be getting bit mask as 1, 1. Okay. Basically, the final array, we need this particular created array to be a mystic array, valid mystic array. So that means every element of this array should be greater than or equal to threshold value. So that means the bit mask required for this particular array should be 1, 1, 1, 1 m times, right? This is one of the observation. And one more thing, you can see this bit mask is actually the OR value of both these bit masks, which of both the rows which I have chosen. That means the question has been again changed to find the number of distinct pairs of rows such that the bitwise OR of both the masks of those rows should be 2 to the power m minus 1, that is 1 1 1 1 m times. That's how the question changed. So now for this question to get to solve this type of problem, we need to calculate the frequency of each mask. Okay, and one more observation over here is as m is up to 8, that means if I'm considering 0 0 0 0 8 times to 1 1 1 1 8 times, that means there are at most 2 to the power 8 bit masks possible. That is just 256, which is very low. So we can easily store the frequency of these bit masks. Okay, now what I have already said, the question is the number of ordered pairs such that bitwise OR of their mask is 2 to the power m minus 1. So we need to find the frequency of each mask. And this is just quick pseudocode, or you can say the algo for this problem now. If I have already stored the frequency of mask in this map, then the solution to this question is just this. Auto IT belongs to map. This is mask comma frequency one, basically frequency one, and this is mask 2 comma frequency. And if the bitwise OR of this mask and this mask is equals to the power m minus 1, that means after choosing these two rows I will be having a valid mystic array. So the count will get incremented by the product of frequency 1 and frequency 2, which is just it1 dot second multiplied by it2 dot second. Let's quickly code this solution. I have already coded this. Let's quickly see the solution now. Initially, I have taken input of n and m, then grid, 2D grid, taken input and threshold also. The brute force solution is same, which I have already discussed. Initially, I have initialized the count value by 0. I have iterated for R1, then R2. Initialize the flag value with true. Iterated for all the columns. If the uh, array array of k is less than threshold value, that means the array can never be a valid mystic array. So I have changed the flag value to false and break the loop. At the end of this loop, if the flag value is true, that means I have a valid combination or valid pair. So count is incremented. At the end, I have returned the count value. You can use map also. Here I have used unordered map. So yeah, for each row, I have calculated the mask value. Initialize the mask value with 0. Then I iterated for each column. If the grid value is greater than or equal to threshold value, then mask basically that particular jth bit, I have set that bit in the mask value, and after that loop I am having my mask and I have incremented the frequency of that mask. Then just initialize the count value, and this loop is same, which I have already discussed in OneNote. That's all about this code. Let's quickly see its time complexity. uh, this step will take me n cross m time plus big of m plus big of n cross m. If this is mapped, you will also have a log of 2 to the power m term. If this is unordered map, this will be big of 1. And this step is just big of 2 to the power 56 square. So overall time complexity of this particular code will be like will be uh, nm square, almost nm square, which is 256 times 256 times 10 to the power 5. And this is, let's see how much it is. Rough estimate, let's say this is 250, so 625 0 0 will almost overall, like, this will reach up to 10 to the power 8, which will not give me TLE. So this is fine. Let's quickly go through the problem again. See if, yeah, basically, let's quickly summarize the problem now. We were we are having a grid of n cross m. We are having n rows and m columns. We are having a threshold array. We have to find uh, the valid mystic arrays, and valid mystic array ARR is the one for in which for each index I, this element should be greater than or equal to threshold of I. And this valid mystic array is formed by using two rows of this grid, say R1 and R2, and ARR of I is nothing but grid of R1 and I, comma, grid of R2 and I, comma X. Yeah, this is array of I. Okay, so after brute force solution, we have discussed that. Let's quickly calculate the mask value for each row of the grid, and the mask value of each row is nothing but basically initialized with 0, and if the grid of I comma j is greater than or equal to threshold of j, then I have just set this particular jth bit inside the mask by using this mask or equals to, this is nothing, this is j, this is nothing but 2 to the power j. Basically, after taking OR with this value, I have set the jth bit in this mask of m bits, right? And after calculating the mask for each grid, each row of grid, I have updated the frequency of that mask plus plus. And after having the frequency of each mask, the question has been changed to find the number of distinct pairs R1 comma R2 such that mask 1 of R1 or bitwise or mask 2 is 2 to the power m minus 1. I have to just find the count of distinct pairs. For that, I was having my frequency map. Count is initialized with 0. I have iterated to all the masks values like this. Auto it1 belongs to map, again it2 belongs to map, and if mask 1 or mask 2 is 2 to the power m minus 1, then count is incremented by frequency 1 multiplied by frequency 2. This is all about the problem, and overall time complexity is nm square in optimal case. So that's all for this problem. After so now we have discussed the max discount one and this problem. Both of these problems has like we have taken from DSA OA. Other two problems, the second and third problem, are from Google OA, which I will discuss later. So I guess that's all for this video. If you are having any kind of doubt, you can ask in Elgo Elite's discussion group or comment section also. Bye bye.